In this video I'll show making and installing the rudder post and servo mount, and I'll show different arrangements. I'll start out with an example on Lutzow here. So nowadays when making the rudder servo mount and the rudder post, I will 3D print it because it's easier to do and also much easier to guarantee alignment. I can show one example of a boat that has a wooden mount, which is how we used to do things before 3D printers were prevalent. Main things for this portion of the build are making sure you have a good robust mount, making sure the rudder post, which is essentially the hole or the tube that the rudder goes through, penetrates the hull, make sure that's in the right location so you have good turning, and then making sure the rudder servo fits in the stern, which can be a concern, and then also making sure you have good relative motion between the servo and the rudder to make sure you have good rudder throw. So this is one setup. So this is using a chain drive. Got this from Servo City. There's plastic chain and metal chain. I will mainly use the plastic chain because it generally holds up. A few people have had it break, but that is usually attributed to if you're trying to use it on a 2-rudder setup with side-by-side rudders, and then some boat hitting the rudder and causing excessive force. For a cruiser like the Lutzow, the vertical height in the stern is going to be an important factor. So you can see here the rudder servo with the sprocket and the chain goes all the way up to the underside of the deck, and that pretty much determines the location fore and aft of the rudder servo. If the stern area is taller, you can get the rudder servo closer, and then sometimes you can even do it with gears. I'll show some examples of that. But if it's a very narrow stern, like cruisers or battle cruisers, I'll have to move the rudder servo further forward so there's enough height for it to fit under the deck. In terms of relative rotation, I'll always try to put a bigger gear or sprocket on the servo and a smaller one on the rudder. That makes it so when a given angle of the servo changing, the rudder will move a greater angle. Ideally getting, I don't know, 135, 150 degrees of total throw on the rudder. And then this mount, as I said, is 3D printed, and I'll show installing one of those. Another important consideration, like I mentioned, is the pivot point on the rudder. So that'll be pretty much where the rudder rotates about. So usually I'll end up with it somewhere around the 1/3 to 40% of the length starting from the leading edge, and that'll sort of give a balance to make sure you have enough throw or enough coverage of the rudder over the propellers. If you move the post further forward, then you'll have more coverage on the inboard prop, but you'll have almost no coverage in the outboard prop when you're turning. If you have it sort of up here, you'll get potentially better coverage on the outboard prop when you're turning, but the distance of where this edge is relative to the prop will increase because of the arc, so you'll lose some wash there. Here's the rudder in Agincourt, a rudder servo mount. So this was one I made out of wood. So you can see it there. So it's totally doable to make these out of wood. When I show the 3D printed one, general idea is just mimic the same out of wood. You know, typically you'll have a sort of U shape, like right here, that the rudder servo can screw into, and then you'll have a post. This is also using Servo City sprocket and chain. For the rudder on this is a printed rudder. So with printed, you can get much more elaborate shapes much easier. In this case, there's also this the little keel thing there. So I have that step to provide good coverage, and then you can see it's around the 40% location, the pivot point. There's the rudder servo in Radetzky. So Radetzky has side-by-side rudders, you can see there, which is generally pretty good for turning. In this case, I have printed gears, and those just mount on a servo horn. And then for Radetzky, the hull is tall enough in the stern here to get the rudder servo right up against it. When you have two rudders, each of them will be about half the size of if it's a single rudder, because all ships get the same area of rudder allowed. So these will be smaller rudders with still, you know, roughly that 40% pivot point. The printed gears here are now my standard, because they're very easy to make and can work in a number of applications. Here's the mount in a convoy ship. You can see here what that kind of looks like. For this one, the difference to point out is there's a idler gear right here between the servo and the rudder, and that is really just for that vertical spacing like I talked about. Also, it can help because you'll want a big gear on the rudder, so the width of the stern, the idler gear allows me to move that further forward. And then sort of just see how it turns. You get a pretty good throw with it. Here are 3 of common rudder servos. Nowadays, manufacturers make waterproof servos, or servos they advertise as waterproof. Probably 10-ish years ago, or up until 10 years ago, we'd have to waterproof them ourselves. But now, several of these come pretty good out of the box. So, start with first. This is a Hobby King servo. So these are the cheapest. I don't know, the current price probably less than $10. I think this is a plastic gear version, but they also come with a metal gear version. And these, out of the box, you can drop it straight into a boat, and it'll last for a pretty good amount of time. Generally, you want to get absolute minimum 1 full battle season with, I don't know, maybe 5 or 6 events out of a rudder servo. Some can last multiple battle seasons, multiple sinks, or many sinks before they fail. But generally, the rudder servo is something you're going to have to replace periodically because the waterproofing just isn't perfect, and eventually they'll die. Here's another one. This is a Traxxas 2075. This one's common. It's more robust than the Hobby King, also more expensive. I've had good success with these. I have a few, like in Missouri and Agincourt, which are, I believe, original. So, I'm talking 4 or 5 battle seasons, plenty of sinks with no issues. So these ones also, I'll just drop them in directly into the boat. The last one is a higher torque servo. Got on Amazon. It comes advertised as waterproof, but I would not put this in a boat. Let's see the model number, or whatever. There's several, from China, very generic servos. Like I said, these are advertised as waterproof, but I've had them fail in the first event when I haven't done anything. So specifically, the failure point is the joint where the wires go in. On this servo, it's just a piece of rubber. There's no adhesive with it. So what I'll do, I disassembled it, and then I coated the inside and then this lower joint with E6000. And this helps prolong the rotor servo life. There are a few other ones. I think there's also a high-tech version, which is probably most expensive. Some people have had success with that. But for most boats, especially if you're starting out, the Hobby King ones generally work. I'll use this one for some of my larger ships where there can be a good amount of torque on the rudder from the thrust. I've certainly burnt out servos from having too much torque on them. When starting out, the rudder servo mount and rudder post install on a boat, some things that have to be done first is I want the propeller shafts installed, because you want the rudder to be right up against the props for better turning. Technically, you could install the rudder post first and then make the shaft fit, but typically the shaft location and the prop location is a bit more complex than the rudder location, so I like to do that first. Once you have it installed, you'll know how many rudders your ship has. In this case, it's the South Dakota. It is one rudder, like pretty much all the American battleships. I think the Pearl Harbor survivors, they all generally had 4 shafts, 1 rudder. I want to determine the rudder size, which I'll go into in a minute, but for these purposes, I know the rudder is going to be about 3 inches long. So if I just sort of put the ruler at 3 inches, you can sort of see where the rudder would be. And then if I do like a 1/3 to 40%, the rudder post would be right about the 2-inch mark. So a little aft of that spot right there. So then I want to sort of see, what the hull height is, to see pretty much how close I can get a servo, and whether or not I need to, whether I can do a geared setup or I need to do sprockets. Another option that was more prevalent in the past, isn't used as often, is a push-pull system. For push-pull, you'll have arm on the rudder. I can show an example of that. And then you'll have a linkage between you usually use a servo horn or maybe an extended one to get more throw, and then you'll have a linkage that goes to the post. I don't like those as much because it's not really an ideal linkage. The throw's limited, and they're prone to binding. So I haven't installed one of those since my very first ships 20 years ago. Some people still use them though. But for this, so I know where my rudder post is going to be. It's going to be about here, and I have some gears. So I have my my standard servo gear, which I made so it just fits right on top of the servo horn, like that, which makes it really easy to adapt. And then I have my standard rudder gear. I make 2 sizes of them. This is the larger size, which should be fine here. So I sort of put, this gear here I'd see that the servo would have to sort of be at like this location-ish, you know, about here. So I'll sort of check the vertical. So looks like there's plenty of clearance there. It would be a concern like if, you know, it was like sticking up, in which case I'd have to consider either a chain or using an idler gear. But it looks like this one I can just do directly from the servo to the post. At this stage, I'll determine the exact rudder dimensions and then the exact post locations because I'll need those going forward. For this, I'll sort of tip the boat on the side and then play around with different rudder shapes. I'll use an index card and then cut it to different sizes, and I can mark the pivot location, and that helps me determine what size rudder to make. So rudders are limited in the think of it as like the area in the longitudinal plane. The current rule is that the rudder area in square inches is equal to the shipped units. So this is a 6.5 unit ship, so it'll get 6.5 square inches of rudder area. General rules to consider, or more of, you know, best practices. You want the rudder height to, at very minimum, be the same as the prop diameter. Ideally, a little bit more. What I found through testing is you'll lose a lot of thrust, usually below the rudder. So going a bit taller, so you have coverage below the rudder, or sorry, below the propellers, is important. So with 6.5 inches, and these props are about 1 inch and 5/8 diameter, that this is going to be a pretty big rudder. In the past, the rules restricted rudder size a lot more, so you had more trade-offs, but this one will be pretty big. And with 6.5 inches, my general thought is, you know, I can make it probably about 3 inches long or so, and then, you know, roughly 2 inches high. And then if you sort of look at, you know, there's an angle here, like it isn't flat, so I will make it, the rudder, have an angle on the top, which gives me a little bit more coverage up top. So what I'll do now is I'll sketch out, you know, what I think good dimensions are and cut it out on the index card. Cut out an example rudder. So in this case it's 3 inches long, and then 2 3/16 are just a little bit under at the midpoint, and there's a 1/2 inch rise across the length. So you can see angle looks pretty good. And I marked a couple vertical lines of where potential pivot points could be. So first I'll just sort of hold it up, you know, see what it looks like. It looks like there's, you know, lengthwise I think it's probably pretty good. Height-wise, it's decent. You know, it's extending a little bit below the propellers, but maybe I go a little bit more. So then what I'll do is I'll pretend I have the pivot point, and then I'll like vary the location and then look at the boat from different angles and then see, you know, pretty much how much coverage I get on the outboard prop, so this prop, and then what the coverage looks like on the inboard prop, and that'll help me determine where the good pivot point is. Sometimes what I'll do is I'll tape a dummy shaft at that location and sort of mark on the hull where the potential pivot point could be, so that little dot, and then that allows, you know, I can sort of hold it there, and then I can look, you know, what sort of coverage it looks like. So you can see the blades in the outboard prop sticking out a little bit, but pretty good coverage, really good coverage actually, on the inboard prop. So then I can shift the pivot on you know, back and forth and see where I think is good, and then finalize where I want the pivot point to be. Shifted the pivot point aft a little bit so it's a bit more of an even distribution. So this is probably closer to 40%. And then you can also look from above. Other considerations are trying to make sure the rudder isn't going to stick out too far beyond the confines of the hull or the profile of the hull. Because if you're turning and someone drives past it, they're probably going to break something. So you can see here, you can get a bit more coverage on the outboard prop in a turn, but downside is the leading edge here would be actually further from the prop. Something I've done more recently related to the pivot point is I've built my ships with multiple pivot points, so you can see the 3 different tubes there on Missouri. So that allows 3 different pivot points. On the Scharnhorst, I have 6 different pivot points per rudder, which is a bit excessive, but that allows testing to really determine what is going to be optimal. One thing I found with rudders is you can design it and have an idea of what you think is best, but until you really get it on the water, it's hard to know exactly which is going to be best for the specific boat and the specific drivetrain you have set up. So I will typically try a few different rudder designs, and then with my new mounts, a few different pivot points, and then put the boat through a set of standard maneuvers, so like a 360 circle, try to determine the diameter and the time to complete the circle, and then also at speed doing a 180 diameter and time to compare performance. Okay, I drew up a servo mount for South Dakota. This one is a new design for me, but it's similar to my old ones. So I'm actually going to put in 3 different pivot points. I believe they're a 1/4 inch apart, center to center. And then I'm going to do a two gear setup. So just the gear on the rudder post, and then a gear on the servo. And then to accommodate the different pivot points, the servo needs to move, so put slots which will allow it to move. In the past I've just had like different mounting points, and I can kind of shift the assembly back and forth. Generally a bit overkill for most people, but it's something I like to do on my builds now. In this one so the hardest part usually about these is getting the, at least from a modeling standpoint, is getting the contour that goes up against the hull. So I kept this one very generic, with the understanding that I'll just cut off whatever excess. For other ones, like the one I have here, this one is specifically for my convoy ship hulls. Because I made many of them, I was more precise with exactly what the bottom surface should look like, and I modeled it so I could drop these directly in the boat. But this is an example of what I call a more standard mount. So you have location for the servo, and this one has an idler gear, and then you'd have the rudder post. Some things to consider are, you want to check the servo orientation, whether with the horn forward or with the horn aft. Typically I'll do it with the horn aft, just because you can sort of see here it gives you some overhang off the end, where if you try to put a gear here, you need a pretty big gear to go up against it. In some ships, like I think Missouri is one of the only examples, you can mount the servo sideways if the beam is big enough. But with the servo horn aft, you want to leave some space for the wire coming out, and just plan for that to go. So in this one I have both space, and then I have that little notch for the wire to come out. My servo lead. Alright, so I have my general mount. Now I'll go about sort of adapting or putting it in the hull. So typically I will I'll drill the hole for the servo for the rudder post from the outside, because it's much easier to get the exact right location because you have the props right here. You can do it from the inside, but that can be harder to tell and get it exactly right where the props are. So I'll drill that hole, and then I'll align it on the inside with the mount, and then I will work to cut the mount down to the correct size for the boat. Drilled a small hole. For the rudder post, challenges are typically drilling a straight hole. Depending on your proficiency with the drill, it can be harder for some than others. I know I typically have a pretty hard time getting it exactly straight. So I'll drill it with a small hole, so just a 1/16 inch diameter, and then I'll use the mount pretty much as a guide when I go to drill it to a bigger size, because you'll want it really to be exactly vertical. Okay, with my first hole drilled, that allows me to align the mount and see what I got to cut out. So I just put a drill bit for alignment there, and then you can see it obviously isn't going to work as is. It'll need to be cut down. So I'll cut it to pretty much make this point flush on the hull there. Keys are to just make sure you have room for the lower edge of the servo, which is kind of easier to see here. Just making sure that there's room for this edge of the servo. This will kind of be your limiting factor, because generally the stern will, or the hull height will sort of increase as you move forward. It'll probably be an iterative process. I'll sort of do a swag, draw it. Generally better to cut less than cut more, and then I'll come back once it's down to the right size. Finished cutting the rudder mount down to size, and I drilled the rudder posts. Again, typically you'd only have one of those. So what it'll look like installed in the hull. There's a decent amount of contact, not perfect, but I'll use epoxy and fiberglass to fill that in. The main things are making sure the rudder post is level, both side to side and fore and aft. Looks like these ones might be sloped forward just a tiny bit. That looks fine. So now I'll just plan to epoxy this in. I'll make sure the posts are up high enough so they go right up to the bottom of the gear there. And then I'll take note basically of how much the servo goes down, and then probably fill in a decent amount with epoxy. For the rudder servo mount, for epoxying it, first I started by putting just a layer of matte down on the contact surfaces to help fill in gaps. Then put some epoxy around the posts, put those in. Put the mount in, I made sure to cover the entire lower surface so it's completely wetted. It'll also help seal the bottom, which was open because of the infill for the 3D printed part. Epoxy in, I made this little barrier, and poured in excess, tiny bit with water channeling, and then also provides a better anchor on the base of the mount. So let this dry, and then once it's dry I'll clean it up. The epoxy for the rudder servo mount dried, and I pulled the tape off. So at this point I'll just clean it up. Usually involves running a drill bit through the posts just to make sure they're clear. Sometimes you'll get a little bit of epoxy in them, not a big deal. And then also cutting them to the correct height, and then I'll just clean up the epoxy. I cleaned up the servo mount and then put a servo in just for demonstration purposes. So you can see the sliding feature works quite well. And then I have my gear. It's mounted onto a servo horn. Put that on, and I can just demonstrate the 3 alternate locations. So I would just set it in place and then tighten down those screws. Try a different one. And the last one there. Alright, that should conclude this video. Covered rudder servos and servo mounts, rudder posts. Hope this was helpful. Thanks for watching.